Hello everyone, today let's solve the problem number 268, missing number. So what the question states here, we are given an array nums containing n distinct numbers. You can clearly see here, we are given an array nums containing n distinct numbers in the range 0 to n. So 0 to n in the sense here, so this is 0, 1, 2, right? So here, we are given an, we have to consider the length here, 1, 2, 3. So n is 3 here in this case. So we have to find the missing number in this case. So when I say missing number, so we have n equals 3. So just give me a second here in this case. So yeah, we are this 1, 2 and 3. We will consider n equals 3 here. Missing number in the sense, now we have the array of numbers 0, 1, 2, 3 we should have. In this case, n equals 3 we have. So number should be 0, 1, 2, 3. In this case, in the array we have 1, 0 and 3. The missing number is 2. So we need to return that missing number 2 as output. So that's what the question states here. We are given an array nums containing n distinct numbers in the range 0 to n. This means one number in this range is missing and we need to find it. So that's what they have given here. So let's come to example 2. Here again, we have two numbers, means n equals 2 here in this case. So it should be 0, 1, 2, right? But in the array, we have been given 0 and 1, right? So we need to return 2 in this case as well. So output we need to return here is 2. Same goes with example 3 as well. Just give me a second here. Same goes with example 3 as well. Here we have been given the nums array. So sorry, what happened here? Oh, this is fine. 1, 2, 3, 4, 5, 6, 7, 8 and 9. So we have 9 numbers. So the numbers we should have here is 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9, right? So the output that we need to get here is we have to find this one missing number. Here you can clearly see 0, 1, 2, 3, 4, 5, 6, 7 and 9 we have. 8 is not present in the array, in this array. So 8 we need to return as output, right? So this is similar to the first and second example. We have now we know what we need to find and what the question states, right? So now we have understood what the question states and what we need to find here. So let's discuss the thought process first, or the approach and the thought process, and let's discuss the edge cases one by one, and then finally write the code and discuss the complexities for the code that we have written. First, let's discuss the approach here. So here in this case, I have considered the same first example here. I have, just give me a second here. I have considered the same first example that they have given in the question, so that it will be easier to understand, right? And we are going with the bit manipulation approach, or XOR approach, we can just say in short. So we are going with the XOR approach, right? So just keep this in mind, right? So the first thing, let's discuss the approach step by step, right? Just give me a second here. The first step here is, we have to determine n. Means here in this case we have nums 3, 0, 1. N in this case is 3. So this is 1, this is 2 and this is 3. We have to determine the n here, first step. So number should be in the range 0, 3. Means 0, 1, 2, 3. That is n. 0, 1, 2, 3. We have already discussed this one during while explaining the example, right? So you should be knowing this one. 0, 1, 2, 3 we have. So second step here is, we will initialize the result. So we will consider the result variable because we have to save the result somewhere, right? For that reason, we'll be initializing the result. So let's initialize the result here. Result equals n equals 3 in this case. We have given here n equals 3 in this case, right? We have been given n equals 3. So I mean we have n equals 3, right? So let's initialize the result to n equals 3. So here in this case, let's come to the main step, or the step 3. Here this is nothing but XOR process. So this is nothing but XOR process. The same thing we have solved for the problem number 136, I think. So here for the single number, I think. the question. The same process we are doing here. We are making use of the XOR here. So if the number repeats again, that will get cancelled, and if the number is not present, that number we will initialize, and the final number in the cell will be considered as output. So the final cell, the final number that is present at the final cell will be considered as output. That we will return as output. Just remember this one. Step. First one is, this is step 1, this is step 2, and this is step 3. So I is 0, 1, and 2. We have this one here. You can clearly see I 0, 1, 2 means yeah, I is 0, 1, and 2. So nums of I we have got here as 3, 0, 1. Sorry, 3, 0, 1 means iterations is 0, 1, 2, 2 iterations. So I equals 0, 1, 2. This is fine. So here in this case, numbers is 3, 0, 1. So this one we are considering. Sorry. So why did I come here? What is happening? Yeah, this one. Nums of iterated value of the nums. First 3 we have, second 0 we have, and third 1 we have. This is fine. So step is fine. Steps are fine. Iteration I is fine, and we have considered nums of I as well. So result XOR equals I we are doing. Right here, this one we are considering. So result XOR I XOR nums of I we are doing. Here in this case, 3, 0, 3. We have 3, 0, 3. So here 3 and 3 get cancelled here. This one and this one get cancelled, and 0 remains here in this case. So in this case, 0 will remain. Result after XOR. Here I have clearly mentioned result after XOR. So same thing we'll be doing with 0 and 1 as well. So 3 we did. We have to do it for 0 and 1 as well. 0 XOR 1, 0. In this case, 0 and 0 cancel out, and 1 remains in this case, right? 1 remains in this case. So we will return 1 here, result after XOR. In this case, we will consider 1, 2, 1, 1 and 1. This one cancels out, and this one remains, and 2 we will return this one, right? We will return result after XOR as 2 here, this one, right? So final answer is we will return 2 as output. So we will be returning 2 as output in this case, right? So we will return 2 as output in this case. So answer will be 2 in this case. So answer will be 2 in this case, right? So answer will be 2 in this case. So here the output that we got is 2, and the output that they have given in the given for the example 1 in the question is also 2. So this is equivalent to the output that we got is equivalent to the output that they have given in the question. So this one approach works absolutely correct in this case, right? So this is the approach that we will be going with. So the missing number here is 2 in this case. We can just write 2 here in this case. So this is the approach that we will be going with, right? So I hope the approach is completely clear. Now let's discuss the edge cases one by one. The first edge case here is smallest input. So when I say smallest input, we are considering only one number. Right here, we are given 1. So 0 here. So n is 1 in this case, right? So n equals 1. When n equals 1, the missing number is 1 here. So the output has to be quite obviously 1 in this case, right? So this is for the edge case, smallest input. So let's go with the second case here. So yeah, second edge case, missing last element. We have 0, 1, 2. So n equals 3. We have already done this one. So n equals 3. Here 0, 1, 2 we have. So this is from 0 to 3, right? So 3 is not present. So 3 is the missing number that we need to return here in this case, right? So I hope this is clear. Missing number is 3 here. So let's go with the third edge case here. Sorry, where did I come? Yeah, third edge case. Yeah, this one we have already seen the example. We have from 0 to 9 except 8 here. So n equals 9 in this case, but 8 is not present. 8 is the missing number. We have to return 8 in this case. So output is 8. So this is for the edge case random order. So I can clearly see the random order, right? So these are the edge cases that we need to keep in mind. The first edge case was for smallest input here. Smallest input. The second edge case was for missing the last element. And the third edge case was for this one, random order, right? these three edge cases that we need to keep in mind. So I hope the approach that we discussed is completely clear along with the edge cases, right? So next, let's start writing the code. So here in the first step, we will initialize the result with n, nothing but length of the array, right? So here we'll be making use of length of the nums array in the code. So just let's initialize the result with n. So I'll just give here result equals nums dot length. So this is fine. So the next step here is, let's go with the iteration. So this will be let I equals 0 less than length of the nums, and let's increment the I here. So the final step here is, we are going with the XOR with both index and array element. So result this one equals I to the power of nums of I. This is fine. So XOR with both index and array element in this case, right? So this is fine. So the final step here is, we will return the missing number, or the missing number remains here. So we will return it. So in this case, I'll just give return result. So this one we have already seen, this one in the approach step by step, right? So this one we have already seen. So I hope whatever the code that we have written is completely clear. So let me hit the run button. I hope this works. Let's see. So you can clearly see here the sample test cases are getting accepted. Let me hit the submit button quickly. So yeah, here you can clearly see all the sample test cases are, all the test cases are getting passed here. So this means the code works absolutely correct in this case. Let's quickly discuss the complexities for the code that we have written. So here the approach that we went with here is bit manipulation. We know that. And what would be the time complexity here? The time complexity would be big of n in this case. So what would be the space complexity here? The space complexity would be big of 1. So why it is big of n here? Because we are iterating through the numbers once here. You can clearly see. And space complexity here is 1 because we are making use of few variables. A result variable here. You can clearly see, which doesn't require any extra space. We are just going with a constant space, right? So the overall space complexity is big of 1, and the time complexity here is big of n in this case, right? I hope the solution or the code that we have written is completely clear. For now, this is it. Thanks for watching, guys.